Okay, this is the typical type of word problem that you'll see with parabolas. It deals with satellites and satellite dishes and that kind of stuff. One of the challenges to doing word problems is understanding exactly what's being asked of you. When you read this one, this says a satellite dish is shaped like a paraboloid of revolution. Paraboloid of revolution. Now that's just a fancy way of saying it's shaped like a bowl. More really this tells you is that it's shaped like a parabola. For our work, we're going to use the parabola equation. Then it gives you some information. The signals that emanate from the satellite strike the surface of the dish, and they're reflected to a single point where the receiver is located. I put a little picture of a satellite dish here. So here's a satellite in outer space. You know, they usually have these paddles on them. You know, and it's usually something like this. This is my artistic rendition. So the satellite's in outer space, and it is sending signals down to the dish, and what happens? These signals, no matter where they hit the dish, they bounce back up to the receiver. So in other words, they focus on the receiver. So our receiver is the focus. That's the idea behind all satellites. Okay, so now that you've seen my pretty picture here, I'm just going to push it off to the side. We're going to do some more drawing here. Now you give us some more information. It says that the dish is 20 feet across at its opening and 6 feet deep at its center. At what position is the receiver placed? So hopefully you can tell from what I just said that the receiver is the focus of all the signals. When it asks for at what position is the receiver placed, what it's asking for is to find the focus. All right? Well, remember we had two equations in which we found the focus. Both of them look like this. X minus hk, x minus h squared is equal to 4p, y minus k, and then y minus k squared is equal to 4p, x minus h. This p part allows us to find the focus. As long as we're using one of these equations, we can find the focus. Now here's the nice thing about a problem like this. You have the leeway to choose which form of the equation you want to use and how you want to orient it. My suggestion, unless you're specifically told differently, is to stick with the x minus h version, really mainly because we're just sort of oriented to think of satellite dishes pointing up or down or something like that. And that's also the math is going to work out better. So with that in mind then, for us to answer this question, we're going to need to find p. In order to find p, we got to create some kind of an equation. Well, here again, this is nice because you have a little bit of leeway. So what I'm going to do is I'm going to put a graphical representation here. I'm going to, because I have the leeway to do this, I'm going to take it and I'm going to make my parabola, and I'm going to center the point HK at the origin. Now, word of advice to you, unless you're specifically told differently, always make HK at the origin. And that's for any of these conics, whether it's a circle, whether it's an ellipse, a parabola, or a hyperbola. Always place HK at the origin. That is always going to be your best bet. And now that we've oriented it upward, this equation right here can be shortened to just simply be x squared is equal to 4py. X squared is equal to 4py because h is 0, y is 0, so all I got to do then is shorten it up. Okay, now we want to find where the focus is. Well, for us to be able to find the focus, we need to know what p is. And for us to be able to find p in this case, we either need to be told something in the problem that says that the focus is so far away, you know, like we've been given, or the other way is if we had a number to substitute in for x and for y, then we can substitute it in and solve for p. So do we have that number? Do we have that? And the answer is yes, it is. I'm going to make that a little bit smaller just to get it out of the way. I'm going to take this out of the way here. The answer is yes, we do. If you look up in the problem, here's what you're told. You were told that the satellite is 20 feet across. That's what you're told. You're also told that it is 6 feet deep. This board is shaking. It sounds like we have an earthquake or something going on here. Okay, now that we know that, do we know a point on the parabola? See, if we want to know an x and y, what we want to know is a point on the parabola. Well, some of you say, yeah, we know the vertex, 0, 0. But the problem is the 0, 0 has already been used. That's part of the equation. We need to pick another point. Do we know another point? We absolutely do. We know two other points. We know this point and we know this point. And if you do your math, you'll find out that this point is going to be 10, 6. And this point over here is negative 10, 6. And you might be saying, where are you getting 10 from? That says 20. Well, remember, 20 is all the way across. Half of that 20 is on the right side, and half of that 20 is on the left side. So we actually do know 2 points, and it doesn't matter which one we're going to use. So let's go back over here, and let's put in numbers for x and y. And again, it's not going to matter whether we use 10 or negative 10 because we're squaring it. So I'm going to put 10 squared is equal to 4 times p times 6. So if I simply just do the math here, I have 100 is equal to 24p. So therefore p is 100 divided by 24. And if you go into your calculator and do that out, let's see, it's going to be 50 twelfths, which is going to be 25 sixths, right? So p is 25 sixths. So we've really answered the question, at least mathematically. However, we should go back and write out our answer better. And so it wants to know at what position is the receiver placed. The receiver is placed 25 sixths. Now, if you want to turn 25 sixths into a decimal, that's about 4 1/6. And what's our units here? Feet. They weigh from the bottom of the satellite. So now we have answered that question. Now just to recap, the idea behind this, number one, is understanding the question and knowing how satellites work, because satellites is a typical parabola type problem using satellites. The other thing is to know that unless you're told specifically something different, you can always orient your figures to where you put HK at the origin, and I would orient it upward only because the math just works out a lot easier. You could have oriented it sideways or downward, but then you would have had to deal with negatives and stuff like that, or deal with your y's in a different way. It's just easier for this. And then we just simply work it through with the math.